The next topic we will be talking about in Unit 3 is complex roots. So some polynomials have roots that contain an imaginary number. This means you will not see them on the graph, particularly a Cartesian graph where it's x and y coordinates. The graph of f of x equals x squared plus 1 is shown to the right. To find the zeros of f of x, we set f of x equal to 0. So when we do this, first we start off with x squared plus 1 is equal to 0. And then we have x squared equals negative 1. When we take the square root of both sides, we have plus or minus the square root of negative 1. And just to remind, the square root of negative 1 is going to be I, which is how we end up with plus or minus I. So complex roots, you cannot see them in a Cartesian plane or one that we've been working with all year so far, where it's an x-axis and a y-axis. But later in the year, you will learn how to graph them on a complex plane, where the horizontal axis are the real numbers, and then the vertical axis is going to be the imaginary numbers. Now, you don't have to worry about this now, but just remember for now, we will not see them on a Cartesian plane, but they will be seen on a complex plane. So just to notate this, I is used to represent imaginary numbers. And there's nothing special about these. Mathematicians, when they were coming up with ways to represent these values, they ran into a negative number under a square root. And they were like, this isn't real, this can't be happening. So they just called them imaginary. So that's how we ended up with the imaginary numbers. Something else is that there are two parts to a complex number. The first part is the real part, and then the second part is the imaginary part. All right, so this is, sometimes people will say, oh, it's imaginary. Yes, the solutions contain imaginary numbers, but the overall root is a complex root because there are two parts. There's the real part and there's the imaginary part. So the key understanding is that all imaginary roots come in pairs. So if a plus bi is a root of f of x, then so is a minus bi. And this is not a coincidence. This is from the quadratic formula. So the quadratic formula with the x equals negative b plus or minus, and then you have the square root, b squared minus 4ac all over 2a. This is why we have complex roots. That plus or minus creates that pair, all right? And we get the quadratic formula. You start with a quadratic function, ax squared plus bx plus c equals 0, and you manipulate it to isolate x, so we end up with the quadratic formula. So none of this is coincidence. It all stems from a quadratic function, and then we isolate x, we get the quadratic formula, and then within that formula, we end up with pairs that could end up being either complex roots or irrational. So those are the two possibilities with the quadratic formula, is that the last resort is that we have an irrational solution, or they could be complex solutions, okay? And these are called conjugate pairs. So some examples below, it says, determine the conjugate of the following complex numbers. Well, we have for I, again, complex roots contain a real and an imaginary part. It's just with this one, the real part is 0, and the imaginary part is 4i. So to find the conjugate, we'll think about the quadratic formula. The real part doesn't change, but the imaginary part does. So that's the conjugate for 4i. Same thing with part B. This is technically a minus 1i. Therefore, the conjugate would just be positive I. And then for C, we have 2 minus 3i, so the conjugate would be 2 plus 3i. And the last one, we have negative 4 plus 2i. The real part is negative 4. The imaginary part is the 2i, and that's where the plus or minus kicks in. So we'll have negative 4 minus 2i. And for now, this is what we need to remember with complex roots, because we will be using the quadratic formula in the next couple topics. So just having an idea of what you're working with as far as complex roots, the parts of them, and their conjugate pairs, it'll help us use the quadratic formula more efficient. All right, hope this helps.